So thank you so much, Daniel, for joining us today. I think you can continue, starting from a short introduction of your good self.
Sure. Actually, I have a couple slides here just after this one, introducing myself, my roles, a little bit of my company, just to kind of give you a background of, maybe the industry a little bit. So this is going to be a presentation about BIM in Canada, kind of the perspective from a general contractor.
Mm-hmm.
Sorry, my slide isn't moving forward here. There it is. So the outline, it was in the, I think, pretty sure it was in the introduction there, but I'm going to talk a little bit, this has changed a little bit. I'm going to talk a little bit about why we do BIM. I think it's important to discuss, why we're driving so hard towards these technologies. I'm going to define what BIM is from a general contractor and from an industry in general, sort of an accepted normal of what BIM is. And I'm going to get into a little bit of how BIM is actually, asked for from clients, how we approach BIM, how we need to approach BIM based on some of the contracts that we are faced with. And that leads to a lot of the industry challenges, right? What clients need is not necessarily what they actually ask for, because they're not really comfortable with the technology and they don't understand how it feeds into what they need. And more important is how clients actually ask for that information. And this provides this introduces a ton of challenge on actually what we can deliver, not logistically, but actually, that doesn't become cost prohibitive. And then I'm going to talk a little bit about what needs to change, or what I feel needs to change in the industry. And then I'm going to dive into kind of what BIM is at PCL. We are the largest general contractor in Canada, and I think we're about 7 or 8, if I remember correctly, in North America. So we're quite a large company. Just go over some of the standard technologies, a little bit of the workflows. I'll show you a model that I'm working on right now. You might be interested. A little bit of our short-term focus and kind of some of the things that we're looking out for. So there's a lot of information. This is me here. I'm Dan Doherty. I wear a couple different hats. One is at CanBIM. Obviously we have a partnership with BIM Pakistan, and that's why I'm here. Our purpose is for the Canadian building industry and infrastructure industry to be global leaders in innovation and technology. So we drive towards that in a few different ways. One of our main ways is we have we used to have a lot of different events in a lot of different cities all over the country. It was a great networking. We're starting to pick that back up, but obviously COVID has thrown some water on that. We also offer a certification process. Certification is quite well received in industry. It's a competency-based certification, and it's I think it's probably the best in the industry. We also have a number of think tanks which we engage industry in, and provide opportunities to our members to actually shape the Canadian industry. Part of that is we have an awards program where we every year we give kind of awards on best in BIM in Canada. Part of that awards and everything else we do, we have a publication, and then part of our services is we actually have job postings, and we have information on all our members on our website. So if you're curious, I'll direct you towards our website, and I encourage you to go check it out. My other hat obviously is at PCL Construction. So PCL Construction is quite a large, like I said, quite a large general contractor. We have more than 30 offices all over Canada, USA, Australia, and the Caribbean. And we do about 8 billion. I think this year we're about 8.5 billion of volume servicing buildings, heavy industrial, civil, and infrastructure markets. We have a couple of our current projects locally here. This is one of the hospitals in Calgary, a $1.5 billion hospital that we're currently working on. This is some of the previous heavy industrial work we've done on refinery plants. And this is one of the projects here in Edmonton. We just finished up Ice District. It was a recreation center where the Oilers play, and a number of different towers and redevelopment in downtown Edmonton. It's just some of the projects that that PCL deals with. So my role here at PCL, I'm manager of operational support. So what that means is we've taken a number of different kind of specialty roles, including BDC, BIM, scheduling, lean, engineering, sustainability, document control. We've taken all these sort of one-off specialty roles that have sort of developed over the last decade in construction, and we've grouped those under one department of operational support. So, the purpose of ops support is to service all our operational needs on projects by introducing different technologies. I myself frame all our technology, engineering, sustainability, everything. I frame that all around lean construction. I think everything we're doing has, it all points towards lean construction, even, technology, BIM, VDC, it's all just, process improvement. We're continually improving the industry by reducing waste, becoming more efficiency, becoming more efficient. That's all what it's all about. That is why I frame everything around lean construction. So as I talk forward in the presentation, get into BIM technology, I look at it from a perspective of, if it's not improving the process and providing some sort of benefit, then we're doing it wrong, obviously. So as we go forward, just keep that in mind. I look at everything through process improvement lens. So why do we do BIM? Everybody sort of has their own answers. All disciplines have their own reasons for doing BIM. Some are which just because general contractors ask them or tell them we need them to do BIM. But really, why, I think it's so important. When we look over the entire industry, all the office jobs, all the manufacturing, all the material producing, all the labor that goes into the building industry, it's a $12 trillion global industry. So that's I think it's about 10% of global GBC is building industry. It's one of the largest industries in the world. Out of that $12 trillion a year industry, up to 57% of all projects end up as waste. Now that's not just material waste, that's time, effort. If you look into lean construction, or lean manufacturing, there's 8 wastes that you track. This is weighting, inventory, defects, overproduction, extra processing. These kind of things all add up to a huge amount of waste on every project. All you have to do is go down to whatever construction project is close to you and watch how it's put together. You can see people walk around, forget tools, look at stuff, have to figure out, go back to drawings, use a tape measure, drawings don't match. It's just an enormous amount of waste. So along that waste, sorry, there's something, I missed the slide there. Along that waste, that's 57%. So let's say half of 12 trillion, so $6 trillion a year ends up as just waste. That's an unacceptable amount of money. And obviously, all that waste with the materials and effort, time, energy, that's extremely bad for the environment. So as industry and as our planet gets smaller and smaller, it's more and more important for us to start using the resources we have more efficiently. So everything we do, that has to do with technology, BIM, is based around process improvement for really one reason, is to reduce waste. And that's obviously not just for environmental reasons, that's for financial reasons. We need to be as efficient as we can because we're all in the business to make money, right? So BIM in Canada, I have a question mark there because, I've been in this industry for almost 20 years. So I've seen almost the entire birth of BIM in the industry, of where it started from and kind of where it's gone to. And I have to say, over that last 20 years, there's been very little movement, and there's been very little movement for a number of reasons, and it's taken 20 years to really understand that. And I'm going to talk a little bit about why that is in this presentation of yes, we do great things with BIM, but we're limited by our contracts for one, how clients our clients understanding of what BIM is, and our point and our part in that value chain. We can't control everything, so we can only work with what we're given, or what the client asks for. So building information modeling, it means different things to everybody. I think this graphic came out from Autodesk. Well, it would be close to 20 years ago, or about that time, where they were just starting to launch Revit, and this was kind of the BIM, right? I'm not going to talk on this too long, but this is sort of the BIM theory, right? We can use information at one point in time through one discipline and pass that on through the value chain to do different things, right? Fabrication, construction, 4D, logistics, analysis. So this is the assumption. We had a building information model that we used for many different things along the life cycle, right? If we turn that life cycle into, let's say, a racetrack, right, up at the start there, everything is instituted, or everything is initiated, sorry, by the client. They say go, they have a project, and through that project we have different groups, different disciplines that all have different roles, right? That starts with probably an architect doing conceptual schematic designs, understanding programming, stuff like that. And essentially they pass that information and that knowledge off to the engineers who take it and further refine it, the design scatting to it, until it comes to the general contractor, who takes it to, depending on the delivery methods, takes it to the trades, and the trades build the building, take it over the home plate, and we're back to the client. Yay, right? This, and then we hand over their building and everything that they want. So that's that's a very schematic building life cycle. The theory behind BIM is along that life cycle, everybody has different technology that they use for their different roles. Schematic designs that SketchUp, and don't pay much any attention to the technology outlined on this racetrack. It's just for an example. But the point is, so we're starting with SketchUp. We have that information. We use Civil 3D. We might do some analysis. Everybody has different BIM information that they're using for whatever they need to use it for. As we pass it off through that, the next person in the value chain, can use that information, or the theory is they can use that information to help them with their scope of work to deliver what they need to deliver, and so on and so forth along that value chain. So really, defining BIM, and this is really what we get into what it is the handoff of geometry and information or data along that value chain in a way that adds value, right? There's no sense in doing it if it's going to cost more money than it's saving, or if it's going to be more effort than it was using paper documents. I think we can all agree on that kind of definition. I'm just going to pause here if there's any comments.
I highly encourage all the attendees, if they have any questions or comments, please you can write down on the chat box on your right hand side.
So I'll continue on. So this is sort of what the BIM theory was, 20 years ago. As we have information, we can hand that off. A number of different standards sort of got developed around that assumption that LOD from BIM Forum. I don't know if you're familiar with the BIM spec, or the BIM Forum LOD spec. That was that was a mechanism for being able to hand off geometry and information in a way that added value. So the assumption is that you can provide the next person in the value chain some sort of value and assurance of the information by using LOD spec. So this is still the prevailing theory in the industry, is we have this geometry data that we're handing off along the value chain that's providing information in the end to the owner. So really that's that's the key, right? Information, geometry, handoff adds value. We're reducing the amount of work because we're not looking at drawings. We have one building information model that we can use. So that was what industry bought into 20 years ago and ran with it. The rest of this presentation is going to go over, the fallacy of why that doesn't work, and kind of how we can change it to make it work. Because the feedback I get on my, wearing my CanBIM hat, I talk to a lot of different owners all over Canada, and they all tell me the same thing. Plus my hat on PCL, I talk to owners, and they all tell me the same thing is BIM is a huge cost for them. If they ask for anything BIM, they end up getting a large bill in the end, and they're not sure that it's worth it. So a lot of them are just backing away. They don't want to do BIM anymore because if they ask for things, it's too expensive. The assumption was that it was supposed to save money because it's going to gather information, but it's costing them a lot of money. And my response is always the same thing. Well, it's because we're not doing it right. You're not asking for it in the right way, and we're not structuring the process for it properly for BIM to facilitate that to save money. And the things that we really need to do, and this is my sort of a personal drive, is to get this kind of information out, is how we can modify the process for BIM to add value. So what clients really need is, in terms of BIM, is they have a building, and in that building they have spaces, and within those spaces they have assets. Those assets are light fixtures or furniture or equipment, mechanical equipment, so on and so forth, electrical equipment, systems. These are maintainable assets that any owner that retains the building will have to manage over the life cycle, right? This is where all the cost saving theory of BIM comes in, where 80% of the cost of a building life cycle is post-construction. That's where that 80% comes in, is taking care of all those maintainable assets, and the time to maintain them. So taking that in mind, what clients really need is something to manage the facilities. So they have their database of facilities management information. And without exception, every client will have some sort of technology stack that they use depending on what the facility is, institutional, medical, whatever, they'll have some sort of stack that'll help them manage everything in the building, right? Capital Planning Management System, also known as a CPMS. This is a big one. Computer Maintenance Management System. Every owner will have a CMMS. Right? That's how they track everything that needs to be maintained in the building. They'll have their computer-aided facility management, their CAFM system, also a big one that maybe have different components to it. Computer document management system. Let's not kid ourselves. We still live in a paper world, and many, 99.999% of owners out there still use document management systems to manage their buildings. So they will have some sort of CDMS. There's also other ones a little more obscure, but they were out there: integrated workplace management, space management system. My wife works in institutional. She works at a Polytech here, and as a space management manager. So she tells me all about their space management system, their work order system, and all the grief that they have trying to get information into it. And of course, their human resource system that will match people to spaces, so on and so forth, depending on what institution you're working for. And they're going to have some sort of record information, right? Usually it's as built or record drawings, right? So if they need to do renovations, they know what the space looks like. They know what, how much space they have, so on and so forth. They know what's in their spaces, what assets are in their spaces, and they have, maintenance wayfinding. They want to know where their valves are, where their equipment is, where everything is within their building. And in an ideal world, those things are linked. Their record information or their BIM is linked with their facilities information, and they talk to each other. Right? When a space is updated within the BIM, the information within their CAFM system gets updated, their record information gets updated, right? So the next person that comes into that space has an updated information all the time. This is extremely important in post-secondary institutions, where spaces are constantly changing year to year. Labs are getting updated into lecture halls, and everything that is in that space, all chairs, furniture, AV equipment, everything has to get tracked, stored, moved, so on and so forth. So this is what clients need. They need to figure out what data they have to figure out to manage their building, what information they need in terms of record drawings, and how that's going to talk to each other. And linking that is that, that's what they need. Most don't have the systems updated to the point where this will actually work. Their CAFM system is a completely separate database that is manually updated based on paper drawings and Excel sheets that one person in the entire facilities management knows. Like, this is the future of facilities management, but this is what clients really should ask for, or this is what they need, right? That's what's valuable to them. But what they ask for, because of the assumption of industry and what standards out there tell them that they need to ask for, is they ask for this as-built model, IFC model, with all COBie information nested in all the maintainable assets. So they want one BIM that has everything exactly where it should be based on what was constructed. And if you click on anything within that model, you'll have all the information you possibly need to manage your building within that piece of geometry. This is sort of the ideal situation of BIM, and it's kind of been what's, this has been the end goal since I got involved with BIM 20 years ago, is this asset-rich database model that we can use for everything, also known as currently the digital twin. What's missing with this is they're not asking for IoT connection devices to monitor their building within their digital twin, to actually manage their building that way. But they're asking for this complete as-built model with all this information. I'm convinced that this isn't what they need. They have, the information within there is going to have to be scraped out and put into their systems, regardless of what we give them. And if it's not the proper format, it's not going to work for them. So really, they need to start at the end, figure out what the format is, and then ask for that, is my point. And I'll get into why this doesn't work. So if we go back to our racetrack and our handoff of geometry and information, that's what they're asking for. This is what we sort of have to plan around when they ask for their as-built model. This is what we need to plan around the handoff of who's going to provide what when, right? What geometry we're going to use for the as-built model, and what information is going to go into. So that's important, because now we get into our contracts, and 90% of the contracts, 99% of the contracts in Canada are design build, design bid build, or construction management. Now, every one of these delivery methods or contracts has one thing in common, two things in common. One is they all require low bid procurement, and two is the contract itself states that the deliverable is paper. Very rarely do clients actually write within their statement of requirements, contractual requirements, that the BIM is contractual and they have to do that, because I don't know why. I maybe think because the assumption is that because they ask for BIM, it's just it's a residual of doing BIM, that they're just going to get this information. The more important one is the low bid procurement. That causes all sorts of problems when trying to put this kind of information together, right? The fact that we have to go out to trades with a design to get them to price the scope of work is what's costing clients in the end more money than it's worth. And I'll tell you, and I'll get into that a little bit. So when we go back to our life cycle, right, the handoff of geometry and information, we see that little guy up there, that signifies that's the stop of the general contractor getting that design and information, going to market and procuring trades to build this building. So what we have to do is take that information. It usually comes in paper form. because that's what's the only thing contractual. More because there is no way to put risk, error and omission assurance on a building information model to send that out to trades. That's one reason. The other reason is 99% of trades don't have the ability to use a model to price their scope. They don't know how to filter it, isolate it, price it, quantify it. And third reason is the models are almost never in the condition they need to be in to actually do that. So as we go to market, this is extremely important. My point is we stop everything, go to market, procure trades, and those trades come with their own information. And once they introduce their own information, that's what causes all the rework. Now we have to go back and update everything that's been done to that point to provide the information to the clients for what they actually want, right? Their as-built model with asset data in it. Now, I'm going to start. This is one analogy is this racetrack. My other analogy to explain why that is such a problem with trades is a Lego house here. So let's imagine our building as a Lego house, and this is the design. We have the finished design. The consultants, the architects have finished it. They've turned that design into a set of building instructions, right? That is usually a set of documents with specifications that explain the form and function, the quality, the materials, everything that has to be, the performance of the building, right? They turn that into, basically the building instructions. We get those building instructions. It doesn't matter what delivery it is. We get those in papers, and we have to go to trades to get them the price, no matter if it's construction management or design build or design bid build. It just depends when that happens. But we all grab those drawings and we go to trades. So we go out, we take those building instructions, we go out to all these specific trades to price all these individual parts, right? Steel, the curtain wall, the electrical, HVAC, plumbing, so on and so forth. I have steel in there twice. Sorry, I didn't update that. So we go out to market. We start pricing everything that we have in those building instructions, right? We have, sorry, my point was, go back to that. We have instructions. We might have the BIM at that point. It doesn't matter. We go out to market with drawings just because that's how our industry works. We don't have the infrastructure or the knowledge in place to share models with trades to actually use them for that part of the process, right? This is just part of the process and how we have to operate. So we go into trades. Now, what happens is we go out, we get price now, we take doesn't have to be lowest bidder, but typically it's lowest bidder on all these trades. Depending on the contract, we can pre-qualify for what we want. BIM is important. If we pre-qualify trades, we can tell them that yes, BIM will be part of their scope. We can price it into the project like that. But when we say, an as-built model of something, depending on the project, their price goes way up. And obviously, everything is cost constraint. So it's up to clients to pick one. Anyway, we pick trades, we procure trades, we get those little pieces, and then we go get into construction, right? So the building instructions, those are the form and function. We get into the trades, that's the installation code and constructability part of it, the means and methods. Now, in terms of BIM, as they get into their means and methods, they take that consultant model. Once we have them on board, we share that model with them. Usually we can get it at this point. And what happens is we start updating everything, right? Because they have to introduce installation code and constructability, everything starts changing. And I mean, everything starts changing. Right, everything except the partitions, essentially. So the steel changes, slopes will change, connections will change, just because of fabrication standards. Sometimes sizes will change a little bit. Whatever it is, things will change. Curtain wall sometimes will get swapped out for a different system. It'll meet specifications and it'll be approved as an alternate system. So, hey, all our curtain wall details that were done up to that point are now redundant. We have to start using a new system. Our HVAC, all that changes all over the place because what comes from the consultants doesn't have constructability built into it. It's, it's basically meant for drawings because we need something to price. So things start changing dimensionally, moving around. Sometimes cable trays will move up and down because some designers don't understand that the accessibility of cable trays has to be in a certain place. And of course, data that comes from manufacturing, from those systems that we're swapping in and out that the client is asking for, that's when this data, a lot of this data starts getting introduced, is once we get trades and they buy out their actual product and introduce it into the BIM. Right, plumbing, same thing. Millwork is another big one. It has to be site verified. Everything has to be designed to fit because, let's face it, walls can be out by half inch, an inch, just all over a large building and tolerances, right? So millwork has to be custom fit. So all these pieces, with trades as we build, come together, change. So what that means is that initial BIM, as we try to update that BIM, we have to either try to update the original Revit model, which is typically what we get, to match the trade information, because that's what the as-built information is, which is, I will say, impossible without redoing all the families within the original model, because design geometry is not construction geometry, and to reconcile the two of them, you have to redo everything. That's why if you want an as-built model, I always direct towards, okay, we'll throw out the design model, we'll put in the trade model, that's going to be the actual fabrication model, and put that within an architectural model, that's going to be the as-built. Lots of problems with that, but that's a ton of work, right? Problem with that is, where does all the data go? You can't put the data within the trade model. So here we are trying to reconcile all this information and geometry into one BIM that is in one program, and some of this stuff just can't be reconciled without starting all over again. So this is why we end up with things like this, and this is not, an anomaly. This happens on every BIM project I've ever been on. Is we have on the left-hand side, we have a consultant model that this was a clash-free model. They spent a year doing coordination on their Revit models to make sure everything fit. It was clash-free. It was an LOD. They called it LOD 300 model, and they handed it over to us and they said, "Yep, clash-free model." And I said, "Great." And I handed it over to trades and they redid the entire model, remodeled everything, built in their access codes, made the geometry actual buildable. They put in their hangers, all the stuff that consultants don't do. Something that was actually installable. So if you're familiar with LOD 300 is, defined as the end of designers. LOD 350 is defined as the geometry that is needed to coordinate and install, right? And then there's LOD 400, which is actual fabrication geometry. But it doesn't matter. This is what happens. We get one model and we have to change everything to make it fit. So we start all over again and we remodel the entire building all over again for coordination. Now we have one model with information, one model with geometry. They don't talk to each other. We have a paper set that's scribbled for as-built. What are we supposed to give the client in the end for an as-built data-rich model, right? Now we have to introduce, another piece of software like DeRofus that we might be able to jam all this information into, an IFC model. Huge amount of rework. I can't stress this enough. And this is just normal. So clients actually pay for the same model, for the same building model twice, just because this is a typical process. So now we end up with a design BIM with, some geometry, a lot of data. We end up with our construction BIMs with a lot of, geometry, but not much data. We have all the manufacturing data that usually comes with paper, cut sheets, that kind of stuff. That has to be plugged back in, updated somewhere. So then we, this operations BIM that the clients are asking for, and then it has to go into some other system, right? We know that that's going to go into some CAFM system that they're going to have to extract that data anyway. So, why are we going through all this, gymnastics of moving this information back and forth and redoing all this in this BIM, this geometry, so they can populate it into probably their own proprietary system in the end. So as you go around that racetrack, we understand, you know, that handoff is sort of a fallacy. There is no way you can hand off information to the next person in the value chain that adds that other information in a way that's just an incremental increase in development in LOD. Like you can't hand off you know, an LOD object at 300 and plug a little bit more information on it and make it into an LOD 350. You have to stop, redesign, redevelop, recoordinate everything, and then call it an LOD 350. So it doesn't make sense, that handoff anymore. So what we need to do is get rid of that handoff and you know, go to more of an integrated project delivery, of course, where that hand is not, it's less of a handoff and it's more of a three-legged race, right? We're tied to each other. We're making decisions to each other. We can introduce the right geometry with the proper information at the right time in that value chain to provide value for the client. There's no rework because we hung our hat on that decision at that point in time and we're running with it for the rest of the project. So, right, this is also where the ISO comes in, is defining that at the beginning and not moving forward until those pieces are defined and plugged in as you go around that track. However, we're stuck in a low bid procurement environment. No matter how much we scream this from the rooftops, we have to stop at a design at a certain point. We need a full design so we can go to trades, so we can get pricing, so we can start all over again and remodel everything. It's just the way it is. So at PCL, we have, you know, a very specific purpose in that value chain, right? We are the general contractor. So, you know, our little portion of the race here, our little people down here, if we were to define our little portion of the race as what's valuable to us right now, you know, BIM at a GC, this is really the big five of what we do every day here. Right out in the front there, this constructability analysis and issue tracking. And I'm just going to dive into a little bit here. We still have some time here, that's good. So I'm just going to exit this, share my screen. What constructability analysis issue tracking is. Right, this is a BIM, this is a project we're currently working on. It's a hospital, about $600 million Canadian hospital in remote location west of here. Anyway, so what we do is we take all our models from all the different consultants and our trades, and this is the design build project. So we are able to get our trades on early to get ahead of that handoff. Now we're still, just because the way industry is and the focus on documents, I still have to have consultants and trades do two different sort of scopes of work, and I'll show you why. So anyway, we take all our different models, we plug it into, this is a program called Revisto. Great program. So now it amalgamates all our models. We go in here and now we can coordinate, we can take a look, we can isolate, identify, take a look at everything we're doing BIM. Here, I gotta close this out. You know, this is where we use we use this for clash detection, we use this for issue tracking. This is one program I love because we amalgamate all the models. It works with Navisworks, which we do our clash detection. And then we actually tag everything within here, you know, within the issue tracker. So this is you know, screenshot from the model, and then that provides information to whoever we're assigning it to. We can put a deadline, we can notify multiple people, multiple companies, and keep track, of all our issues within here, filters out. I'm not going to get into the specifics of this program, but that's something that's valuable for us. Somebody must have changed it because now I got to resync. So this is a live model. So I'm having to resync right now because somebody within Canada, we're working with people from Toronto, from Vancouver, from Calgary, from Edmonton on this project. Somebody out of the 120 people on the team that we have in this project just updated something. Now I'm syncing, it just synced, and now this is up to date. So it could have been an issue or whatever. So as we go through here, we have, I'm just going to clear these filters. So we have 526 issues in here that we're currently tracking. Right, we have a conversation that tracks every time something gets touched within this project, it gets tracked within this conversation. It also ties in the 2D documents. So everything that's 3D, here, I'll see if I can find, there we go. So all the issues that are 3D tracked are also tracked within a 2D set. So all our 2D documents are also, that are generated within the BIM, are within here. I'm just going to open up one for an example. So we take our floor plan, our issues, our tracking stamps, we call them, are on the drawing that are associated within the model. And if we want to overlay, we can take that drawing and overlay it with the model, so we know exactly where the drawing is on the model. Zoom in here a little bit so you can see what's far. So now we have a drawing on the model, and we can move. Now we can take our model and move it around that drawing to see exactly what's going on with the drawing. So if there's an issue in the model, we can see the stamp, we can see the drawing, and we can see the model all in one view and assign that to people. So this is an invaluable tool for us. This is something that, general contractors, we amalgamate all that information. Keep in mind, this has nothing to do with asset data. This is just geometry. This is just us coordinating everything that goes into this hospital, tracking everything, what's going on a huge team that's dispersed all over the country. So that's, so that's something that, every view, I'll just go into one more, just as one more example. So every view in every drawing, including the sections, are tied to the model. Now so this is a great quality control tool for the guys, for the team on site. They can take this, they can look at the drawings, they can make sure that the geometry is matching the drawings, and there's no, dimensions or 2D details that have come in as, boilerplate that we, that are going to cause risk, right? This is all the model data that we can actually tie into it and see available on the iPad, so people can take this onto site and look at it on the iPad and, provide this kind of data and link to everybody else all within one environment. So this is just a great tool we have, get into mechanical spacing. I could go on all day on this, but we're running out of time here. So this is just one tool that is extremely invaluable to us. I'll go back to my PowerPoint presentation. So that's constructability analysis, issue tracking, right? That's our clash detection, our spatial coordination, our tying everybody together. We also have, we do a lot of reality capture, quality control, reality capture, our 3D scanning, our drone stuff. I'll show you a little bit of that. Actually, in fact, I'll show you a little bit right now. We also have, an entire drone fleet all over all our offices. So these are just some of the flights we do. I have 9 here in my district, all over this part of the world. I'm just going to zoom into one and show you what we use it for. So this is just one of our industrial projects. This is a drone flight we did. This is one drone flight we did. I think we ended up doing 3. What we do is we tie this into a GIS system, so our corner system, and then we can track our progress on a slide ruler. So just this is, a scalable orthographic image, high definition image. We can turn this also into, or this is just a control. There's our slide ruler. We did one in winter, one in summer. We can also turn that into a 3D. So just going to show you one thing here. Right, so if we want to get into, I did this offense. Pause, hold on, give me a sec here, it's loading. So what this does is now, because we geolocated this drone data into, oh, this is not, try a smaller one. Because so we've tied this drone data in with survey control, now we can take like elevation, XYZ elevation on anything, on any point on this. Okay, so something happened here, dang. So with an update here, you know what, I'm gonna do something else here. So I'm gonna do, yes. So I'm gonna measure, I'll just show you because my example got deleted out here. So I'm gonna take the volume tool and I wanna do that volume right there. Now, meters, so I'll take that volume. I can take this and just that fence I have, you know what, I'm gonna modify this a little bit. I'm gonna pull that over there. Turn this base surface on into a mesh, turn this into a mesh, turn this into a digital terrain map, turn this into, I'm going to compare this to a different mission, so a different flight. Turn that into a mesh. Now I have a 3D surface that I can do cut fill with based on our drone flight. So you can see here I have you know, this big mass here is actually our garbage disposal here. You know, I can take this fence and I can put that over anything on any point where we flew over, and I can start comparing flight over flight and getting cut fill. You can see here blue and orange. One is so the blue is the fill, or one is one flight, the orange is the other flight, and it gives you a net cut fill here at the bottom. So this is one of our drone, our GIS, our reality capture. We also have our 3D scans and stuff. We do the same thing, but it's more terrestrial based. Let's go back to my presentation here. We also do a ton of BIM for business development. Part of business development is we'll do 4D analysis. I do want to show you one 4D here. We use this to really tighten up our schedule, as well as use this as a tool to provide the client, you know, information on how we're going to put the building together. So this is just a 3.5 minute video. It's worth working of a 4D animation of a new hospital we're building in Vancouver. So this is an existing parking lot site. You know, we talk about our cutoff walls with our excavation. You know, that's how we're going to reduce the seismic loads on buildings. Excavation. We really wanted to define everything that's going on. You know, we have our timeline. You know, we do road works first. Our site, you can see our trailers arrive. This is when we mobilize. Our cranes go up. Our parkade starts. You can see on the lower left there. You can see how is a plan view with the north arrow. You can see kind of how our slabs. This is exactly how we're going to put our slabs together. How our cranes are going to work in tandem to put you know, such a big floor plate together. This hospital is about I think the end contract was just over $2 billion, so it's an enormous building. So you can see our slab is still going up. This is when the envelope begins. We actually have 3 different layers on our envelope to show our core walls, our insulation walls, and then the cladding that goes on the outside, just to show you know, exactly our sequence, how we're staying right behind the structure. Once the envelope gets to a certain way, then we feed in the mechanical. We start mechanical. We're filling the envelope. You know, this is the money shot, as they say, the city in the background. So I'll just say this 4D analysis, this took about, I think this was 5 different programs that this took to do it. It was a combination of InfraWorks, SketchUp, Revit, Synchro, and one more program. And in the end, it was, Premiere Pro, Adobe Premiere Pro, put it all together. But anyway, my point is, this takes a ton of different technology and programs and knowledge and work. This is what is important to us as the GC. This is what adds value. This tells the client exactly what we want to do, how we're going to do it. And this was Lumion. So it actually was 6 or 7 different programs. Right, and this just tells the client exactly how we're going to put the building together and what they can expect. So that's important. And then digital asset management, this guy here in the background is catching up. This is something that is starting to be asked for a lot, but like the rest of my presentation said, it's not really asked for properly. So we are struggling in the industry on how to actually make that work in a way that's not cost prohibitive. We can do anything. We can create an as-built model that's down to a half-inch tolerance is what they're asking for, but it's going to cost you 10 times more than what it's worth. So what we consider, BIM is we don't really consider BIM anymore. It's more integrated construction technology. It's, Internet of Things. It's 3D printing. It's artificial intelligence. It's robotics. It's our drones. It's a reality capture. It's everything taken together to provide value to us by improving process. Has to provide process because we're right on the cusp of, this is, I'm sure everybody saw this in the news, 3D printed bridge over a canal in Amsterdam. The next phase of this is actually having 3D printers on site to do this kind of stuff. This is not far away. I can see 3D printers putting our structure together on buildings. Right? This is coming. This is less than 10 years away. So we need to be on top of everything technology. This is something we've created within PCL, our Job Site Insights platform. Right, it's our Internet of Things. We have a number of different partnerships. We create our devices for us, our sensors for us. We created the platform and we plug that into our, a Power BI dashboard to provide information. This is some of the value that gives us, right? We put these sensors on heaters, on everything in our site, right? We have gas sensors, humidity sensors, leak sensors, temperature sensors, air quality sensors. We put all this stuff on and then we track everything. So this is just a heater. We can turn on and off now based on temperature automatically instead of keeping them run, all night long on a slab pour. We can save a ton of money. On one project, we saved over $180,000 because we turned our heaters off during parts of times of the day. Just because we were comfortable doing that, we weren't worried about our slabs freezing, right, in the wintertime. In Edmonton, it gets really cold for a long time of year, so this is a big problem for us. And this is also technology that's getting smaller, getting more efficient, getting more cost effective, and technology that's already proven. So these are things that we have our eye on. Robotics, mobile technology, not robotics in terms of having robots put drywall up, but automatic machines. We already do this with our drones. But hey, this is a different kind of drone, backfills, track hose, stuff like that. We can run this 24 hours a day. We don't have to worry about people, quality control isn't a thing because it's running off a program in the background. This is something that's extremely appetizing for general contractors. It gets rid of all safety constraints because we don't have to worry about hurting people. The working hours are reduced. We can work 24 hours a day. We don't have to worry about hiring skilled workers. Repetitive motion stress, that goes back to safety. Inconsistent, productivity because the machine works the same way, based on a computer, the same way, the same speed every day, all day. It takes away also the human error. So this is something that we are dreaming of, is when robotics, obviously robotics comes with, a host of other technologies, 5G connectivity, artificial intelligence, this kind of thing. All these these technologies all coming together, congruent technologies parallel technologies coming together to really change the industry. So that's really where we are in Canada. I'm going to leave 5 more minutes here for questions, but that's really where we are. where there's momentum. Clients are asking for, the right stuff. They're just not asking for it in the right way. So, general contractors, our hands are really tied. We are extremely constrained on how we can work with the rest of the value chain to provide this information, this data and geometry in a cost-effective way. It's just costing too much money because we're not doing it properly. We're not writing our contracts around BIM. We're plugging BIM into existing contracts, and it just doesn't work. So I'll leave it there for questions. That's all I had for you today.
Thank you so much, Daniel. I think you have very well presented and explained as a general contractor's perspective. So I have a general question here, like where you see Canada standing, like in BIM implementation as a general contractor.
Like if you like on a scale of 1 to 10, where are we in the world?
Yes.
Ooh, that's tough. And to be quite frank, I would say we're 4. I think we are throwing a lot of money and time at technology and BIM for the wrong or in the wrong way. Uh, Everybody is still working within their silos because our contracts are set up that way, and we don't have a national mandate because our provincial jurisdiction and our national jurisdiction don't want to interfere with the market to mandate something that will change, the competition in Canada. I think it needs to happen, and I'm pushing for it, but that hasn't happened yet. That's one reason, Singapore, Australia, Europe, United States. I can name 10 different countries that have mandated some sort of BIM on level because they see efficiencies there, right? We haven't done that as a country, and that's why I think we're behind the 8 ball. I don't think we're on that scorecard. I don't think we're faring very well. I think we still waste a huge amount of money on processes and standards that don't work, and there's just too much misinformation in the industry.
Yes. And Pakistan, we are still struggling, and we have a long journey ahead, like for BIM implementation to our projects, construction projects. So as we know, like as a general contractor perspective, like we know, like implementation of BIM can help you, like in your change order management, in your conflicts detection and the resolution, and the facility management areas for sure. So I think it is a really game changer for the industry, and we have more to come. So